This quick video is going to take you through how to use the Desmos graphing calculator to solve absolute value inequalities. Now, you are welcome to play around with this, experiment, see what else you're able to do, but I think this is a very valuable resource when it comes especially to checking your work. So absolute value inequalities tends to be one of the more challenging things that we cover in Algebra 2, and to have a graphing utility be able to kind of check your work to see, if you've done the algebra right is a huge asset. So the inequality that I'm going to put in here is 2 times the absolute value of 2x minus 3, then minus 4 is greater than 10. You can rewind it if you need to hear that again, but I'm going to type it in the box on the left-hand side here. So 2 times the absolute value. So if you're wondering where to find that, you have your show keypad, and then in your keypad, you'll see your absolute value. In my absolute value, we are going to type 2x minus 3, and then I'll hit my right arrow to click out of the absolute value, and then we'll have a minus 4. Now, right now, it's graphing the function. We're going to put in a greater than. Notice you can do a greater than or equal to, less than or equal to. For this, we're just going to do greater than, and this is going to be greater than 10. Now, right now, I just have the 1 in there. Okay. So it's kind of fun to play around with that. You can do a lot with the graphing utility there and just kind of change the number and see how changing how any of these numbers affects the solution. So to read the solution off of the graph, what we're going to home in on is just the x-axis here. So where we would do this on a number line, if we were doing it out by hand, Desmos is doing it on the coordinate plane, which means we're getting a 2-dimensional graph instead of a 1-dimensional graph. So what we're going to do is just fixate on the 1 dimension, which is the x-axis. So look at where it's shaded. Remember that when you're graphing anything, you're essentially shading the solution set. And you can see that it is shaded from -2 and then to the left. The dashed line is the 2-dimensional equivalent of the open circle. Okay, and what that means is that the -2 is not included in my solution set. And so we know that the solution set would be x is less than -2 because we are shading to the left, and that's where our numbers are less than. Or, coming over here, we have the line at the 5 here, and we are shading to the right, which of course is greater than. So this would be x is greater than 5. So my answer to this inequality is x is less than -2 or x is greater than 5. Okay, now just to play around with it, let's go get rid of that greater than and replace it with greater than or equal to. And now you'll see that I have the same graph, except instead of the dashed lines, I have solid lines. And a solid line is the 2-dimensional equivalent of the colored in, shaded, or closed, whatever vocab word you'd like to put in there, circle. And so this would be less than or equal to -2 or greater than or equal to +5. Now, because graphing utilities are really good like this, like what would happen if I replace this with a less than? And notice that the lines are in the same place. They're in the -2 and the 5, except now less than. Remember, absolute value means the distance from 0 is less than is going to put us closer to the 0 as opposed to further away from the 0. And so this would be all of the numbers in between -2 and 5, not including the -2 or 5. And that's that dashed line there, which is the same as the open circle. And of course, I could change that to less than or equal to, which would make the lines solid. And what I would encourage you to do is not to necessarily fall back on this as your first line of like this is how I'm going to come up with the answer, because we do want to work on those algebra skills, but it's a great way to check your algebra skills, particularly if the answers you come up with are not integers. So -2 and +5 are pretty easy to see, but if I change that number to say a 9, now you'll notice that where these lines are, I don't exactly know where the lines are. on here. So I wouldn't necessarily want to use this to actually solve this inequality, but I definitely could use it to check my algebra and to know if my algebra answer was reasonable. So this is going to be -1 almost to -2. Okay, and this is going to be almost to 5. So like, I don't know if it's 4.6, 4.7. I don't know what it would look like as a fraction. Like, I haven't done it out. Okay, but definitely something that you could use to check your answers or check your work. You can also put the equal sign in there, okay? And you're, again, looking for where those lines would be placed. So it's a really, really valuable tool. And just make sure that you're using it appropriately. You're using it to check your answers. You're using it to eliminate answer choices on a multiple choice test, know when you need to ask questions to me, and so forth. But that is how you can use Desmos to do absolute value inequalities.